afternoon. In this session, we discuss a new term called gravitational field. This, I think, will be hearing the first time. We define the Newton's law of gravitation, that force between two masses. Let there will be a mass capital M and another mass small m, separated by a distance r. Now, you got the force of attraction between them as F equal to capital G into M divided by r square. Now, if I want to find the gravitational field of this capital M at this particular point, how we are going to use this equation? So, first of all, you must know what is meant by gravitational field around a mass. It is actually the region around a mass over which its influence can be felt. That means this capital M will be having its own region around it. In that region, if this small m comes, then only there is a force of attraction between them. So, that influencing region is called the gravitational field of that mass. Now, suppose I want to find the gravitational field mathematically at a particular distance r due to this m, then we consider the masses here, capital M, and influencing this one at this particular point. For that to be known, you have to keep a mass at this particular point. That mass is having its own gravitational field, but that field is not influencing this one. Okay? So at this particular point, the influence of this one alone is coming, but still I am keeping a small mass over there. So the exact mass for gravitational field E will be equal to limit m tending to 0, capital G into m divided by r square. What it means is that m will be such a small value, very close to 0, but not 0. Then, if it is such a very small value, then its influence on this one is not there. That is, small m is not influencing capital M. Instead, capital M is influencing this small m. Okay? So, this is the exact concept of what you call the gravitational field at a distance r from capital M. Now, how this can be made exact? Because this is a variation m tending to 0. Tending to 0 means you will be taking it in many different ways. Now, let us change that concept into what I said is the influence of small m not come on this capital M. Now that we can take it mathematically, small m into capital M has to remain capital M only. That effect of this small m should not come on this. So capital M remains as capital M. That is possible only when m equal to 1. Mathematical multiplication identity. So in this sense, I can treat this small m to be 1 unit mass. Then, if I keep that unit mass at that point, then that field E becomes equal to capital G into m by r square. So this is the exact equation for gravitational field due to capital M at distance r from the mass. So mathematically, how we are going to define it? gravitational field at a point is defined as the force acting on a unit mass placed at that point. Force acting on a unit mass placed at that point. Okay, so exact definition is this, but we want to get a correct single equation that is possible just by taking this mathematical multiplication identity. Okay, therefore we can define in terms of unit mass. Clear? This is gravitational field. And those who are very inquisitive, this equation you are familiar with in 9th standard. You might have studied in 9th standard. But there you got this field magnitude to be equal to small g, acceleration due to gravity at the place. So gravitational field and this acceleration due to gravity are having the same sense. So this is all about the gravitational field. If only field is there, then only the force is there. Because you see this one, if I write force F equal to capital G into M by R square, this is nothing but F equal to small m into E. This is what the formula we are getting. Therefore, definitely we can say, if this small m wants to experience a gravitational force, it must be in a gravitational field. So this is the relation between field and force. Alright? And that is how you have got that weight of a body is equal to m into g. Getting the idea? So that this g is acting as what? The magnitude of field at that point due to F. Alright? That's all.